Hello guys, have such a great day. Alright, well today we're going to start with this brand new topic for our physics class, which I believe you're going to find really interesting because it involves a lot of maybe terms that we're going to normally use in our physics class. And as this topic you have seen it as well in maybe junior high. You had seen it in junior high, actually, in second grade, and I believe you had found it easy, maybe, not, let's say, not too complicated, because the terminology around it is kind of, but the way to obtain this topic is not quite difficult. But first, before telling you what this is about, let me show you a video that I found because I believe you're going to find it funny the same way as I did. So let's play it, all right?
I'm applying for a new villain role. Go by the name of Vector. It's a mathematical symbol. Quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Okay, so with this, what the name of this guy, which I found really interesting, but he defines himself really well. We're going to talk about vectors actually, and he said that a vector is an arrow with both direction and magnitude. So there's a relation between the direction and the magnitude of it. Because normally, and let's play our presentation. All right. When talking about vectors, for example, surveyors use accurate measures of magnitudes and directions to create scale maps of large regions. All right. We could not imagine like if we draw each piece of land and trying to find with it, I don't know, a lot of measures. It would be impossible, right? So surveyors use these measures, the length of certain places or spots in the world, and then we join them together, but to find the direction and the magnitude of them, which magnitude means the distance, the length, all right, they use these vectors. So physics is the science of measurement. We normally measure length, we measure the weight, and we measure the time. So we begin with the measurement of length, its magnitude, and its direction. So for vectors, we use them to get this these amounts, these numbers, these magnitudes. So we begin with the measurement of the length and its magnitude and the direction. Like we said before, the surveyors use it for make scale maps. They know the distance between Mexico to Michoacan, for example. But how do they plot them? All right. So in physics, that's what we do. We use these magnitudes, these measurements, in order to get results or numbers and classify them, and as well know how the world works. So distance is a scalar quantity. A scalar quantity, the difference between the scalar and the vector is that the distance is the length of the actual path taken by an object, but just the distance. We can know the distance from I don't know, your room to the entrance of your house, but what is the direction of it, all right? So the length, the time, the mass is just one scalar quantity because it is just one quantity. We're actually measuring only one point of it. But I'm sorry, it contains magnitude only and consists of a number and a unit. All right, like 20 meters, 30 grams, 25 seconds, etc. All right, it just has one magnitude, which in this case is 20 meters. I'm sorry, 20, and the number and the unit, which would be meters. All right, and then we find we find here in the Cartesian plane a plotting of what we're looking for. But what is the direction of this? How do we know that? All right. So the displacement is a vector quantity. All right. Displacement is the straight line separation of 2 points in a specified direction. All right, remember this, we saw it in mathematics when we found the slope and the line, etc., in which we find the initial point and the finishing point, let's say. That's a straight line. But the displacement is the distance from where it starts to where it finishes. Okay, so let's say in this very example that we have 12 meters and this has 20-degree angle right here, but this line moves along this way, but the distance from the first point to the next one, from A to B, should be, in this case, my vector, okay, because it has magnitude, which is 12 meters, but it also has a direction, which in this case is 20 degrees. All right, it could be 10 degrees, it could be 90 degrees, etc., etc., etc. You can find it in all of the angles along your circle, let's say, but the vectors are defined always by a magnitude and a direction. Okay, a vector quantity contains magnitude and direction and number, unit, and angle, all right, which is letter D that we have right here. 12 meters, 30 degrees, 8 kilometers per hour, north, I'm sorry, which is what the N means here. Distance and displacement. Displacement is the x or the y coordinate and position. Consider a car that travels 4 meters east, then 6 meters west. All right, so we have our Cartesian plane right here, and the car travels 4 meters east, okay, and 6 meters west. Once he got to the 4 meters east, he travels back 6 meters west. So what happens right here? We take the 4 meters from the distance he already traveled and minus 2 in our Cartesian plane, because remember this is our initial point. So he in total travels 6 meters west. So the x goes from +4 and the x goes as well to -2. All right, so this gives us more accurate example of what vectors are. So net displacement is 2 meters west. All right, what is the distance traveled? What do you think? All right, the distance traveled is 10 meters. All right, because he went 4 plus the 6 that he went back, that's in total 10 meters. All right, you guys, I think with this example you're going to find it more you're going to find it easier. That's the word. Identifying direction. A common way of identifying direction is by the reference to east, north, west, and south. So we're going to locate the points below. Where this point right here is going northeast. All right, northeast. Remember that we always mentioned before the y coordinate and then the x coordinate. So it goes northeast 50 degrees. So the length of this vector is 40 meters. And it goes 40 meters, magnitude, 50 degrees, direction, which is the northeast, okay? Then we have another point right here, and it goes northwest to the opposite side, okay? And it has a 60-degree direction. The magnitude should be the same, which is 40 meters, but it went 60 degrees northwest. All right, 60. We're taking this one because from here up to where we get to the vector is it's 130 degrees. No, 120 degrees. I'm sorry, right here. But what we try to get is the north. Since we're saying northwest, all right, that's when we use this angle, not the opposite one. All right, then the third one is traveling southwest, all right, or west south. It's southwest. So the magnitude is the same, 40 meters, 60 degrees southwest. And the final one is right here, which is 60 degrees southeast. Okay, the magnitude should be the same. In this example, it's not that every single time, it's just this way. All right, you guys? Now, write the angles shown below by using reference to east, south, west, and north. So, in this case, we're traveling southeast, 50 degrees. And we're traveling here northwest 45 degrees. So we're going to see the answers. This is 50 degrees southeast, like we said before, and 45 degrees northwest. All right, you guys? Okay. So we can also use polar coordinates to identify vectors, and they're an excellent way to express vectors. Consider the vector 40 meters, 50 degrees northeast, for example. So we are here. So we are located right here in the northwest quadrant, and my vector should be 40 meters, and it has a 50-degree northeast direction, all right, which is this one. R is the magnitude and the theta is the direction. All right, you guys? Always, 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 every single vector should have a magnitude and a direction. All right? Polar coordinates are given for each of 4 possible quadrants. Like we said before, northeast, southwest, northwest. Then we have southeast. Southwest and southeast, right? Which is this one. All right, and we can count them as counterclockwise or clockwise from from our plane finishes to where the vector starts. All right, and we can use as well rectangular coordinates like this ones. Reference is made to x and y axis with plus and minus numbers to indicate position and space.